Good morning.
Good morning, Jeff. Okay, guys. Now, before I start, does anybody have any question at this moment? Anything that we talked about yesterday that's still not clear? So far, everything is good?
Yeah.
Okay, good. Thanks. Okay, guys, let's just talk about, yes, okay. I'll just briefly mention some other units that we, as okay, may come across. So yesterday we talked about things such as time, speed, distance, or length, as we may refer to. We said area, we said volume, and we talked frequency, we talked mass. Another unit that we will come across is going to be as okay, what we'll call power. Okay, now power, that's mainly as okay, just going to be as okay, we can say it's okay, the rate of transfer of energy. Now power, that's going to just okay be having the units. I have the unit that we call watts. Okay. So watts. Just like the same watts as okay, as your light bulb. Okay. Now this can be as okay. You can have multiples of the watts. A common one would be as okay, something like okay as kilowatts. Clear, okay. You can have fraction of watts, which is going to be as okay, milliwatts. Okay. But generally speaking, as okay, the standard unit for power is going to be watts. Okay, and that's going to be as okay, one of those variables that's going to be as okay, be determined by as okay, the amount of energy that we are going to be talking about. We have something that we call intensity. Now, intensity is mainly as okay, there's going to be as okay, we say as okay, the concentration of. Now, some people may say it's okay, energy, or some people may as okay, just say power per area. Okay, so this mainly as okay, even if you as okay, just look at the definition of intensity, it's mainly as okay, going to just okay, help you to build up the unit, because okay, that unit for intensity is going to be the unit of power, which is watts, by the unit of area, which was any unit of distance squared. So we can say it's okay, for instance, okay, centimeter square, for instance. You can take meter square, you can say millimeter square, as long as there's any unit of distance being squared. Okay. Is that clear?
Yep.
So if for some, yes, okay, things, yes, okay, the definition itself will give you, yes, okay, the unit. Okay. Now, guys, another thing that is okay, some people, yes, okay, may confuse then as okay, intensity with is going to be, yes, okay, what we call density. Now, the thing that's going to be is okay, similar between intensity and density is that, okay, yes, is going to be is okay, a concentration of. Well, it's okay for intensity, it's okay, we're going to be concentration of area, sorry, of energy or power over an area. Intensity is okay, is going to be a concentration of mass over volume. As you guys remember yesterday, when we talked mass, that's okay, all of us say it's okay. It could be a kilogram, but it's okay, we can have multiples of a kilogram. That's going to be pretty rare. Okay. But it's okay, we may have it's okay, fractions of a kilogram. Okay. Which could be as okay, things such as a gram. A further fraction of a gram is going to be as okay, a milligram. Even a further fraction of milligram is going to be as okay, we're going to call a microgram. And so on, so on. Okay, but as long as, okay, yes, it is a unit of mass, but okay, yes, you can use that. Clear? Okay. Now, what we said yesterday was that the standard unit for volume was liter. Okay, but again, yes, okay, this can be, yes, okay, divided into smaller, smaller, smaller subunits. Okay, clear? Okay, so you can go as, okay, deciliter, centiliter, milliliter, microliter, so on. But generally, it's okay, no matter what, the unit for density is going to be as, okay, any unit of mass by unit of volume. Any questions?
No.
Okay, guys. Okay, just the last one. And again, it's okay. That one can also be, it's okay, confused with intensity. And it's going to be, it's okay, what we call pressure. Now, pressure again is okay. Just like prayer, it's okay, intensity, and density is going to be, it's okay, the concentration of But here, yes, okay, it's going to be concentration of force per area. Okay. Now, your pressure can have, yes, okay, 2 units. Generally speaking, yes, okay, it can be, yes, okay, what do we call a Pascal? Oh, number 2 else, sorry. I guess Mr. Pascal is going to be pissed. Okay. But if you, yes, okay, want to make the unit from the definition, now the general unit of, okay, force is newtons. Just talking about, yes, okay, the force of gravity. Okay. Per area, which could be, yes, okay, any unit of distance squared. So as long as you take any unit of distance, you can say it's okay, meter squared. You can say it's okay, millimeter squared. You can say any unit of distance, but as long as it is squared, it becomes an area. Okay. Any questions so far?
Nope.
Okay. So these are mainly going to, or you can say it's okay. This was pretty much all, yes, okay, different factors, parameters, exacta that we will be coming across through this course here. So if you talk physics, yes, okay, this was the real physics. Oh, yes, okay, the actual only, yes, okay, physics that is going to be, yes, okay, applied in this course here. So everything got a unit. The only thing that doesn't have a unit is going to be a percent. Okay, does anybody know what a percent means? What does the word percent mean? You just have to translate it, that's all. Now, when I say that, okay, as the passing percentage for this module here is 75%. What would that mean?
Pretty much like per 100, right?
Per 100, okay. So per 100, cent, just think of a century. What is a century?
100 years.
100 years.
100 years, right? Okay, so per 100, that mainly is okay. Okay. So that's okay. 75% that means that, okay, yes, if the total score of a class or test was 100, or you had 100 questions, you have to answer at least 75% or 75 of those questions correct to get the required, yes, okay, 75%. Clear? Okay. So that's just saying, yes, okay, had it been a total of 100 points, yes, okay, what would you have been getting? Because you're not going to have 100 questions in all your tests. Okay. Did that make any sense? Okay. You may have, let's say, it's okay, just 50 questions on a test. Okay. So yes, okay, whatever you got right out of those 50 questions, let's say it's okay, 40 out of 40 out of 50. That's what you got right. But then you get a percentage. And that percentage means that, okay, I had this test, I had 100 questions. I had to be a total of 100 points. This would have been the points you would be getting. Clear? Okay. But percentage is always going to be unitless. Okay. So there are going to be as okay. Maybe it's okay, just 2 or 3 incidences, just okay, where we were expressing something as in terms of percentages. Okay. Did that make any sense? Okay. Any question? Now, the details about it's okay, each of these things that we talked about, it's okay, we'll come across them. And we're going to, it's okay, we'll talk more about it's okay, the relationships between, it's okay, the parameter and okay, yes, what makes up that parameter. Okay. Now, what we're going to do is, okay, let's talk about, yes, okay, our powers of chance. And what I said yesterday was that, okay, yes, your metric system. Well, okay, it's very easy. So you can say it's okay, convert from a bigger unit to a smaller unit. Or from a smaller unit to a bigger unit. I'll say, well, okay, how many of the small units do we have in a bigger unit? Is going to make up a bigger unit, and vice versa. It is pretty much okay, very standard in your metric system. Just if I ask anybody, does anybody know how many ounces you have in a pint?
16.
Okay. So out of how many? Yes, okay, out of 7 people, there was only 1 person who was able to answer that within.
I said it, I just didn't say it to you.
Okay. So you expect me to understand telepathy?
No, but you can't always hear 2 people talk at once. So Christian said it when I was saying it.
I got 2 ears. No, okay, that's fine. But like, okay, clear, okay. But then yes, okay, if I ask her, yes, okay. Now that was just for yes, okay, volume, right? Okay. But then I will ask you, yes, okay, how many inches do you have in a foot? That's an easy one, guys, please. Don't let me know. 12. But then how many feet do you have in a yard?
3.
Okay, here you go, right? Okay, so it's not the same number. Clear? Okay. Okay. Now, how many liquid ounces do you have in a gallon?
64.
120.
Oh,
It's some weird numbers, right? Okay. Okay. So it's not the same whether you take mass, volume, distance, so on, so on, so on, so. Okay, for different as okay parameters as okay, you have to multiply them or divide them by different numbers. Okay, but that's not how it goes in the metric system. So that's why I really don't know. Yes, okay. Good. Anyways. So yesterday, yes, okay, what did we do? Scooby-Doo, what did we do? We made a line like this, right? Yeah, okay. Now, there's nobody that said that you can't make it this way, but I just do it this way, it's easy. Okay, and what we say is, okay, at some point, what did we have? We had, okay, that's what we call the 0 point, right? You guys remember that?
yep.
Good. Okay. Now the point here that represents that's okay, the 0 point, we're just going to call that the basic unit. And you can actually, it's okay, take the unit of anything and put it here. Clear? Okay. We can just, okay, yes, to be simple, we can just, okay, for instance, okay, say distance. And in the metric system, yes, okay, there was a meter. Did you guys get that?
Yep.
Good. Now what we have here on this side, well, I just says, okay, this is our 0 line, right? Okay. Yeah. Now what we have on this side here is mean is okay, going to be, it's okay, we can say it's okay, going to be the multiples of our basic unit. Yeah, okay. Whereas we have on this side here is going to be is okay, the fractions of the basic unit. Which we in this case is okay, choose yes, okay, we say well, we are going to talk about distance. And whereas okay, the basic unit of distance was a meter. Did you guys get that?
Yep. Yep.
Good. Okay. Now, the first one is going to be, yes, okay, what we can call a deca. The next one is going to be, yes, okay, what we will call a hecto. The next one is going to be, yes, okay, what we will call a kilo. The next one is going to be, yes, okay, what we will call a mega. And the next one is going to be, yes, okay, what we will call a giga. Okay, so all these are going to be, yes, okay, multiples of the basic unit. Yeah, okay. So you can have, okay, a decameter, you can have a hectometer, you can have a kilometer, you can have a megameter, you can have a gigameter. Okay. Now, what is it that the deca is going to mean? 10. What is hecto going to mean? 100. A kilo is going to be 1,000. Now, a mega, guys, is not going to be 10,000. It's actually, it's okay, going to be a million. Now, how do you write a million? It's 1 with 6 zeros. So this one is okay. If you don't want to sit down, it's okay. I have to count on the zeros. Sorry. This 1 million can also be written as 10 raised to the power 6. Okay. Whereas giga is going to be as okay, a billion. But actually, that's what going to is okay, be 1 followed by 9 zeros. Okay, so we don't really want to sit there and actually, it's okay, count on the zeros. So that's why it's okay. Scientifically, it's okay for big units like this. They may go and say it's okay, 10 raised to the power 9. That's going to be the case. Okay, how to express a giga. Did you guys get that?
Yep.
Any questions about this? Okay. Now some of you say, okay, why only million and billion? Well, okay, nobody forbid you to just, okay, go like this, 10 raised to the power 1. There really no need of writing as, okay, the 10 raised to the power 1. Because it means, okay, it just means multiply by 10. For 100, you can write, okay, as 10 raised to the power 2. 1,000 or a kilo as a factor, as it can also be written as, okay, as 10 raised to the power 3. Yeah, okay. Now, guys, likewise, it's okay on the fraction side. When we go, the first one is going to be as, okay, what we'll have is a deci. The second one is going to be as, okay, what we'll call a centi. Third one is going to be as, okay, what we were calling a milli. Fourth one is going to be as, okay, what we call a micro. And the last but not the least is going to be as, okay, what we call a Okay. Now, guys, a deci actually or me is okay 1 cent. A centi is going to be as okay, we can write it as okay as a 1/100. A milli is going to be as okay 1,000. A micro is going to be as okay 1/1,000,000. And a nano is going to is okay be 1/1,000,000. Did you guys get that? Okay. So all of these here is okay were fractions. But what I also say is okay, they could also be expressed as negatives. So if you want to write them as okay an exponent form, yes, okay, this a deci is going to be as okay in 1 raised to the power. Or 10 multiplied by 1 raised to the power minus 1. Centi is going to be as okay 10 raised to the power minus 2. A million is going to be as okay 10 raised to the power minus 3. So is a micro, which is 1,000,000, is going to be as okay 10 raised to the power minus 6. Or a billion is going to be as okay 10 raised to the power minus 9. So what we actually as okay can say that okay, yes. Let me just what these negatives here is okay implicate is that all these units here is okay were fractions of the basic unit. Well, okay, here we wrote them as fractions. But what I also said yesterday that okay, as anything that can be expressed as a fraction can also be expressed in a decimal form. Yeah, okay. But that same deci, which was 1/10, or 1/10, or we can say 1/10, could be expressed as okay with an exponent as 10 raised to the power minus 1, but can also be written in a decimal form as 0.1. The centi, which was 1/100, or we can say 100, was expressed as okay as this. The exponent is going to be as okay 10 raised to the power -2. But the same number as okay, or the same, if you're going to as okay express it as a decimal, you're going to be as okay 0.01. So for your milli, 0.001, which was 1,000. So for a micro, which was going to be as okay 0. This much. Also for a nano, which was going to be as okay the billionth. This much. Okay. So you can see that okay, as for these big numbers, yes, okay. It's a pain to yes, okay, write it in a decimal form, because then you have to sit there and okay, yes, count the zeros. So that's why it's okay, they may just okay write it as an exponent form. Yeah, okay. But as far as the value is concerned, it's okay. All these here is a nano. All these here are micros, are worth the same. All these here are millis. All these here are centis. All these here are decis. Did you guys get that? Okay. Now, each of these, because okay, in science, if that's what you want to call it, okay, everything is okay, is going to is okay, maybe symbolized. Okay. Yesterday, you, for instance, said that, okay, yes. What's his name? We wrote, for instance, okay, the word hertz. But the symbol for hertz was, sorry, Hetz. We just talked about another unit this morning as okay, it was watts, for instance. Why is just going to be as okay expressed with a unit, a symbol, W. For instance, okay, when we say meter, it's going to be as okay symbolized by the letter M. Right, okay. Did you guys get that?
Yep.
Okay. So likewise, yes, okay, each of these units here are going to, yes, okay, be represented by a symbol. So you don't have to every time write, yes, okay, mega or giga or centi or milli or micro or nano. Okay. So mainly that's okay, expressed using, yes, okay, one or two small letters, single letters. Okay. That I mean is okay, represent earlier you talk about a giga, a mega, a kilo, a deca, deca. Deci, centi, milli, micro, nano. Okay, so the symbol for giga is a G. As a matter of fact, yes, okay, an uppercase G. Did you guys get that?
Yes.
The symbol for mega is an uppercase M. The symbol for kilo is K. The symbol for hecto is H. The symbol for deca is DE. Well, okay, the symbol for deci is mainly as okay, just D. Symbol for centi is C. Now, symbol for milli is still going to be an M, but please keep in mind, guys, that that's going to be as okay, a lowercase m. So for mega, which was okay as a multiple of the basic unit, we are going to just okay express that with a uppercase M or capital M. Where okay for milli it's going to be expressed with a lowercase m. Did you guys get that?
Yeah.
Okay. Now micro is a little unique fellow. Okay. Now you can't say, well, okay, so what do we do? Do you just write okay as an even smaller m? That's okay, yeah, this is micro. No. Okay. So for micro, yes, okay. It can be expressed either with the unit, yes, okay, with the symbol MC. May represent just okay what we call micro. Okay. Or, and this one here is more as okay, commonly used. It's going to be as okay, this Greek symbol here. And what we actually just okay call this fellow here is mu. So the name of this symbol here is mu. But what this mu here is going to represent is going to be the symbol for micro. Is that clear? Okay. So if it's for instance, okay, said meter was okay as our basic unit. Okay, but if you want to write micrometer, is going to mu m. This is how you write micrometer, for instance. Did you guys get that?
Yep.
So you're probably not going to see as okay MCM. Okay, most likely as okay this symbol here, followed by as okay the unit of the like it says a symbol of the unit that you as okay used as a to yes okay measure it. Okay, guys, let's see. Now the last one is nano, and nano is mainly as okay just a simple lowercase n. Were you guys around when they launched iPods?
Yeah.
And the iPods just ended up becoming smaller and smaller. And so yes, okay, at some point, it's okay, it became so small that they called them an iPod Nano. Okay. Okay. But then yes, okay, the memory became bigger and bigger. Now, some of you may not have seen those because they existed before, so yes, okay, most of you were born. Whereas, okay, the first computer disks that they used to have was this big. Then they came down as, okay, as some smaller disks. Then they started things such as CDs. Then came DVDs. And what just happened was that, okay, yes, the storage on those disks just increase. So one of those is, okay, big floppy disks, as we used to call them back in the days. Only had a couple of kilobytes, which is nothing. Forget about, yes, okay, saving a picture on those. Right, okay. So, but then came as okay CDs. Now, usually as okay, basic CDs would be as okay 720 megabytes. Then you have DVDs, 40 or 4.2 gigabytes. Okay. And now you have clouds. Yes, okay. Okay, you can store all your data on the clouds if you want to. Just hope that that cloud doesn't fly away and it starts raining, because okay. Okay. But it's okay. Again, you can say it's okay. Now, what is a byte or bit? Well, okay, we talk about that in a later chapter. But that's just going to be, you can say it's okay, the unit used for, you can say it's okay, digital storage. So kilo was a smaller storage. Then you end up having megas, and then it becomes in gigas. Then so now, okay, something more, okay, this is tetas and things like that. Okay. Obviously, they're going to be okay, greater and greater and greater and greater multiples of the basic unit, which in this case here was, or computer storage was, byte. Here we said meter. Okay. Now you're probably not going to hear somebody saying, yes, okay, well, okay, I just traveled a distance of 700 megameters. Okay. Now, guys, out of these units that we are talking about here, let me just tell you, okay, which are going to be the ones that you most likely will be coming across in the text. It's going to be kilo. It's going to be mega. Practically, while in the text you may not hear gigabytes, okay, I may ask about gigas. As far as dekas and hectos are concerned, yes, okay, you're probably not going to hear those. Okay. But you still need to know, okay, what a hecto is, what a deca is. Now, as far as, okay, as our fractions are concerned, you're probably not going to hear, yes, okay, the deci. But yes, okay, we will be talking a lot about centi. We will be talking about milli. And we will be, as okay, talking of micro. You're probably not going to, as okay, come across nanos. But never say never. So does anybody have, yes, okay, any questions about these units here? So you can mainly say, okay, for the first three, yes, okay, just 10 times 10. And then you go, yes, okay, increasing it 1,000 times. So you can actually say, okay, 1,000 kilos of any unit is going to be 1 mega. And 1,000 megas are going to be 1 giga. That makes sense.
Yeah.
Now you may go as okay and say, okay, is there a mnemonic to yes, okay, remember this one here? Yes, there is. And we can actually, now you can make up your own if you want to. Nobody says that you can't. Or we can just say that, okay, yes, do it this way. So our mnemonic is going to be that great master king Henry. You may not like the word, yes, okay, you may not like King Henry. You can go be by King Harry. Though he's probably not going to become king ever, but anyways. Okay. Doesn't. Usually. Drink. Chocolate. Milk. And what things gives milk? Not chocolate milk.
Goats.
Huh?
Goats.
Okay. What else gives milks?
Cows.
Cows. And what does the sound? What's the sound that a cow makes?
Moo.
Okay. And if you yes, okay, I serve something that you don't like, what would you say?
No.
Nah. Okay. Okay, so Great King Master, oh yes, okay, Great Master King Harry doesn't usually drink chocolate milk. Moo. Nah. Now, guys, any questions?
No.
Okay, guys. So is this clear so far?
Yeah.
Okay. Now, guys, one thing. And okay, yes, we can mean yes, okay, just try to it's okay, reproduce this thing here. That's fine. I can run this. So basic unit. And we said deca, hecto, mega. No, sorry, omega. What the hell? Kilo. Now we have the mega, and then we have the giga. We had okay on the other side we had deci, centi, milli, micro, and nano. We said that deca was 10 raised to the power 1. Hecto was 10 raised to the power 2. Kilo was 10 raised to the power 3. Mega was 10 raised to the power 6. And giga was 10 raised to the power 9. Or which could also be written as 10, 100, 1,000, million, and billion. Whereas this was 1 over 10, 1 over 100, 1 over 1,000, 1 over a million, and 1 over a billion. Or we could also write it as 10 raised to the power minus 9, 10 raised to the power minus 6, 10 raised to the power minus 3, 10 raised to the power minus 2, and 10 raised to the power minus 1. Or even as okay at a decimal form. Like this. Now, guys, one thing is that your nano and giga are reciprocals to one another. Likewise, can we say that, okay, yes, micro and mega are reciprocals to one another. Likewise, kilo and milli, or milli and kilo are reciprocals to one another. And the centi and hecto are reciprocals to one another. Likewise is a deci and deca reciprocal to one another. Because what I said yesterday was that, okay, yes, if anything is increasing a million times, and another factor or parameter is reciprocal to that, it will become That's going to be expressed as a nano. If something is increasing a million times, the other factor that is reciprocal to that is going to be in 1 millionth or a micro. If something is going to be expressed in kilos, other unit or there is option or factor that is going to be reciprocal to where it is expressed in kilos may be expressed in millis. So for centi and hecto and deci and deca. Clear? Okay. But another thing to be also said that as was a must for us things to be reciprocal is that yes, the product of them was going to be equal to 1. So guys, it doesn't really matter. You can pick any one of these up here. Let's say that we take the nano. Or let's say it's we take the giga. Now just for simplicity's sake, it's we're going to write it like this, 10 raised to the power 9. This was your giga. 10 raised to the power minus 9. Clear? Okay. Or this 10 raised to the power minus 9 could also be written as 1 over, 1 with a 9 zeros. This 10 raised to the power 9 here actually has over b is 1 followed by 9 zeros. So when you multiply this by 1, it becomes a billion divided by a billion. So what you get? You got 1. Clear? So that's because nano and giga are reciprocals of one another. Likewise, even if you do the same for micro and mega. Here it says a mega, that was yes. Where you multiply that by a micro. Like this. So how are you going to say it's 1 million multiplied by 1 divided by 1. Or is it 1 million cuts out another 1 million. And what you still have is this. But what it confirms is that the reciprocal of micro is mega. Likewise, the reciprocal of milli is a kilo. Because one is 1,000, 1,000. One is 1,000. But if you multiply it, 1,000 by 1 over 1,000. It comes out to the same. Okay, how do you want to do it this way? It says, 1,000 multiplied by 1 is 1,000 divided by 1,000, and yes, you cut it out and it becomes 1 like this. Or you straight away go like this. Here's the product size. Is that clear? Okay. Now this reciprocals of these units here is mainly as something that you just need to take along with you. It's going to become hopefully as more relevant and sorry, easy to explain once we talk about as okay factors which actually as okay are reciprocals of one another. And it will say yes, okay, listen guys, one here is expressed with a unit of kilos. The other will be expressed in terms of millis. Because these two here is okay were reciprocals of one another. Clear? Okay. So just take as okay these compare as okay are these connections together as okay with you to the next chapters. So one thing that you can say is okay, what was the two criteria for reciprocals? That the more one increase, the other one is going to equally decrease. Because okay, we are talking about two factors which were reciprocals. So if one, as I said, is okay, increase 1,000 times, the other one will decrease to 1,000. Okay, but then keep in mind, guys, okay, as those two separate factors or parameters are going to have as okay their own units. Okay, so one will become as okay, let's say as okay megas, the other one will then become milli, or vice versa. Clear? Did that make any sense? Okay, so if I say as okay, something increase 1 billion times, it become megas or gigas. And the other one will become a nano. Clear? Right, okay, you go milli, then kilo. Because one increased 1,000 times, the other is going to become 1,000. Did you guys get that? Okay. So just take that with you. That okay, yes, even these units here, yes, okay, are reciprocals to one another. Because that's going to be as okay, easy as okay, figure out as okay. Because it's okay, the unit of the worth of something which may be reciprocal to another thing can be expressed with this unit here. That's the simple thing. Okay. Now let's take a short break, guys, and okay, that's when we come back. What we may do is, yes, okay, I will try to, yes, okay, wake up, yes, okay, you inner mathematician. Okay, and say, okay, yes, how will you convert from, yes, okay, a bigger unit to a smaller unit, or from a smaller unit into a bigger unit? Okay. Did that make sense? Okay, so what we do. If you guys have a good understanding of money, well, okay, let's keep all your change, bigger and smaller bills on the table in front of you. Okay, because okay, we may use that. Again, yes, okay, as an example. Just to make it, yes, okay, easy to understand how this is. It's okay, mathematically done. Let's put it that way. Okay, guys. So would it be fair enough to say that I see you guys in 20 minutes? Brew your coffee, fill up your cups, bring your popcorns, whatever. So see you guys in, it's okay, 20 minutes. So, any questions yet? No? Okay. Let's see if we can change that. It will change now, okay? Okay. Everybody clear about this, right?
Yep.
Good.
Yep.
Now, just before I get into it, is there anybody who doesn't know what 10 raised to the power 6 means? Well, okay, yes, it will become, yes, okay, a million. Which was going to be, so, yeah, okay, 6, like this. But what 10 raised to the power 6 actually means is that, okay, yes, 10 is multiplied by itself. Six times. Clear? Okay,
Yep.
good. So if I say it's okay, 10 raised to the power 4, would there be anybody who could tell me it's okay what that will be equal to?
$10,000.
10,000, right? Okay. If I say it's okay, 10 raised to the power 5, it will be
100,000.
exactly. If I say 10 raised to the power 7, ten raised to the power 7.
10 million.
10 million. Okay, Christian. Let some of the girls answer you, okay, man? Okay. No shit. Okay, guys. Now, what we will say, for instance, let's say that we got, something expressed in thousands. Let's say, for instance, okay, we have 1 kilowatt. Is that clear? Clear, okay. Now, 1 is 1. Okay, you can take any number. You can say it's okay, 4, you can take 5, you can take whatever. Now, this kilo here is actually going to be as okay, or we can say 1,000, right? Right? And watt was mainly as okay, just it's okay, the unit of power. Did you guys get that? So we have as okay 1 kilowatt. Now, if you want, yes, okay, say, okay, this 1 kilowatt, how much is that going to be? It's okay if we are expressing it in terms of megawatts. Variation is okay, go from a smaller unit to a bigger unit. Because a mega is greater than a kilo. Right, okay, but we want to just, okay, express the worth of 1 kilowatt using the unit megawatt. So our question is going to be that 1 kilowatt is going to be equal to how many megawatts? Now, what this 1 kilowatt here actually means, that's okay, is 1 kilo was 1,000. So yes, okay, you can write like this. And watt. So that could also, yes, okay, be simply written as 1,000 watts. Clear? Okay. That same 1 kilowatt can also be written as 1 multiplied by 10 raised to the power 3 watts. Did you guys get that?
Yeah.
Good. But that same kilowatt, if we want to express its worth using, yes, okay, a megawatt. That is going to become 0.001 megawatt. Or what we actually could say is, okay, was going to be as okay, 1,000 of a megawatt. Or we could say it's okay, this 1 over 1,000 actually is okay, could be 1 multiplied by 10 raised to the power minus 3 megawatts. Did you guys get that?
Yep.
Good.
Yeah.
Whereas, guys, if we, let's yes, okay, go the other way around. Let's just, okay, as for the simplicity's sake, that, okay, as we had the same 1 kilowatt. Okay. But we want to say, well, okay, as what is going to be as, okay, it worth, or what is going to be its worth if we express it as, for instance, okay, or you may call it, okay, a decawatt. Okay. So how many watts is that 1 kilowatt going to be if we express it in a decawatt? Well, okay, guys, that is going to be 100 decawatts. Now we also know that, okay, this 100 here is, okay, can be written as 10 raised to the power 2. Okay. Now what you see here is when we went from, yes, okay, a smaller unit to express its worth using a bigger unit, the numerical value became less. Whereas the opposite happens here. The numerical value increased. Because I would hope that everybody will agree that, okay, yes, 100 is greater than 1. Or 1 is actually also going to be, yes, okay, greater than 0.001 or 1,000. Clear? Okay. So what we do, guys, for instance, okay, as we did here. When we want to, yes, okay, determine the worth of a smaller unit being expressed with a bigger unit. Okay. You actually, yes, okay, will multiply by a fraction. Or what multiply by a fraction will mean is or divide. Whereas, okay, if we do the opposite, as we did here. Where we want to express, okay, the worth of a bigger unit being expressed in a smaller unit. We simply multiply. Did you guys get that?
Yep.
Okay. But multiply by what? Although here it's okay, we say it's okay, we multiply by a fraction, or multiply by a fraction is the same as saying it's okay, just simply dividing. Okay. Yeah. Okay. But what do we multiply by, or what fraction? Oh, yes, okay, what simple multiplication? That's going to be all dependent upon, yes, okay, which unit you are converting from into which unit. Now, guys, yes, okay, here just look at the exponent values. Because what we can say here, for instance, these were our exponents, right? Right?
Yeah.
Good. What is the difference between these two exponents here? What's the difference between the two?
Like the amount difference is 3.
Yes. 3. Okay. Likewise, that's okay here, although not written, but it's okay here. It's okay, our exponent would be a plain one, right? But
Yeah.
here, it's okay, our difference is, the difference is
1.
2. Huh?
From 3 to 1. From 3 to 1 or from 2 to 1?
3 to 1.
Oh, 2.
2. Clear? So what was it that I multiplied by here? Because yes, okay, here we multiplied by, what was the difference? Or 10 raised to the power, that's okay, the difference of the exponent. And that's how we end up actually saying that, okay, 1 kilowatt was equal to 100 decibars, right? Or decawatts, sorry. Whereas over here we said, well, okay, the difference between, yes, okay, the two exponents was 3. So actually, as you can actually say, okay, multiply by 1 hour, that's okay, 1,000. Or it could be saying, yes, okay, just dividing by 1,000. Did you guys get that?
Yes.
Or if you don't, well, okay, yes, that's where your currency comes in play. You may have $100 bill on your table, right? If not, for now, just assume. Clear? Okay. Now you may go to the bank and say, well, okay, yes, okay, I got this $100 bill here. I want to get some change. Now, physically, you only got $100 bill. Now, the number of bills that you have is one, just one piece of paper, right? Clear? Okay. Okay. But that single piece of paper is okay, is worth $100 because it's a $100 bill. You go to the bank and you say, well, okay, yes. Can you give me change of this in cents? So what are you going to get now? 10 bills that each is going to be $10, right? Clear? Okay. So the number of paper bills that you get, sorry, that number is greater, but the worth of each bill is less. Now each bill is only worth $10, right? Did that make sense? Okay. Now, how do you get that? Okay, that $100 is going to be equal to, yes, okay, $10 or $10 bills. Well, okay, that's the math. That's the conversion that we do. So when we actually say, okay, convert from a bigger unit to express its worth using a smaller unit. A $100 bill would be a bigger unit. A $10 bill would be a smaller unit. Did that make sense? So what did we do? You straightforward, multiply it. You could take that $100 bill and say, well, okay, listen, give me dollar bills. Now everybody would know, yes, okay, how many dollars would you, or how many bills are you going to get? 100 bills, right? Or notes. So that number is, the number of bills that you get is now greater because their worth is less. Each piece of paper, each bill is only worth $1. But the number of bills that you may have to sit there and count one by one, one by one, one by one is going to be greater. Did that make sense? Now the other way around, you have, okay, yes, $1 million bills. God help that poor teller who got to sit and count those, right? But you go to the bank and say, well, okay, you know what, buddy? Here's $100. It's okay, $1 million in dollar bills. I want to get this change into $10. Give me, it's okay, $1 million in $10 bills. So he or she will have to give you, it's okay, 100,000 bills, right? 100,000 $10 bills, right? Or you brought those $1 million in and say, well, okay, give me this in 100 bills, then he will give you, it's okay, 10,000 bills. Did that make sense? Any questions? Okay. So this may get, okay, but it's merely as okay, just a matter of, you just need to know two things. First of all, it's okay, which of the two units that are being talked about is greater? And which of the two units that we are talking about is smaller? Is that clear?
Yeah.
Good. Okay. The second thing that you will know is, or need to know is, okay, since one is bigger and one is smaller, how many times bigger is it that the bigger unit is compared to the smaller? Or vice versa. Which is just going to be as okay, the reciprocal of one another. Because, as we said, oh, that's just simple. Let's say, yes, okay, $1,000, right? Okay. What could that give you? That can give you 10 $100 bills. Right, okay. It could give you 100 $10 bills, right? Right, guys?
Yeah. Yep.
Yeah.
Okay. So if you look at them, yes, okay, this multiplied by this. Sorry. They become, yes, okay, reciprocals. Or you can say then this multiplied by this, yes, okay, there will be reciprocals. So if you went from, yes, okay, smaller to bigger or bigger to smaller. So just keep in mind, guys, okay, yes, we can write it down. It says, okay, when you want to convert from a bigger unit. For example, here we can say, okay, we said earlier mega. 2. We can say, okay, express. Or you want to say, okay, express, determine its worth using a smaller unit. Let's say it's okay, kilo. You will multiply. Yeah, okay. In this example here, it's okay, since we said mega was 10 raised to the power 6, kilo was 10 raised to the power 3. So we can mainly say, okay, what are we going to just, okay, multiply by the difference of the exponents, which in this case here was, we could say, okay, 3 subtracted from 6, which will give us wait. Did you guys get that?
Yep.
Good. Whereas in the other case, when you want to convert from a smaller unit. Now let's just say it's okay, kilo, as an example. Okay, 2 is okay, either is okay, express. Or as we may call it, it's okay, determine its worth using a bigger unit. You can still see it's okay, mega. Now this is where you can say it's okay, we can do 2 things. You will either multiply by a fraction or simply divide. Well, let me write it out. Multiply by a fraction of what? Or divide by what? Again, that's okay. A difference between the exponents. And what about the difference of our exponents here as well? It was the same. Since we use the same units, right? Okay. So kilo was okay, yes. Sorry. I'll say yes, okay, 10 raised to the power minus 3. And mega was 10 raised to the power 6. So it's okay, the difference between, yes, okay, the exponents are still going to be 3 minus 6. For instance, yes, okay, which is going to end up as being 3. But that's going to be as okay, the exponent of what you will divide it with. Just like here, it's okay. It is not going to be as okay. You're going to as okay multiply it by 10 raised to the power as okay, the difference between the exponents. Did that make any sense? So that's okay in, let's see, it's okay, this example here, let's just okay, make it colorful. What will we do? They want to express as okay, so it's okay, determine the worth of something expressed using a unit of mega. Now using a unit of kilo. And then multiply by 10 raised to the power 3. Where did we get that 10 raised to the power 3 from? That's okay. That 3 here is determined by the difference of the exponents. I'll simply say it's okay that 1,000 kilos make up 1 mega. Whereas on the other hand, as we see, it's okay down here. Now we could do that in 2 ways. You could either multiply by a fraction. Now that fraction is going to be as okay 1. Now we know that okay is 1 multiplied by as okay 10 raised to the power. What's the exponent here? 3. So this 1 over 10 raised to the power minus 3 here actually can be as okay the same as saying 1 over 1,000. Clear? Or you can simply say as okay that we could divide it by 1,000. Did that make any sense?
So you can
Just to get the number.
multiply it by a fraction or divide it by
By
a
a simple number.
Okay.
Listen, you can take any number, my dear. Look, if I say, let's make it simple. Oops, shit. That's not what I meant to do. Look, I say, for instance, okay, 1 multiplied by 1,000. Clear? What do I get?
1,000.
1,000. That was what we had here in the red example. Now I can say in the blue example, and that's what pretty much okay is what you asked about. I can say it's okay, 1 multiplied by 1 over 1,000. What would that mean? Well, okay, it just becomes 1 multiplied by 1 divided by 1,000, right?
Okay.
Did that make sense?
Yeah.
So what you still get, you get it's okay, 1 over 1,000. Did that make sense?
Yeah.
So that may be the same as saying it's okay that you divide anything by 1,000, right?
Okay.
Okay. Mathematically, yes, okay, it comes out to the same. It's just okay as a different method. Okay. But the whole thing was, okay, how do you know what to multiply with? Or what you have, okay, what fraction to multiply with or divide by? That's going to be determined by, it's okay, you can say it's okay, the difference of the exponents. That's the cheat. But it's okay, if you know it one way, the other way around is just going to be it's okay reciprocal. Because you say it's okay 1 kilo or 1 mega, for instance, is made up of 1,000 kilos. Clear? So 1,000 kilos will make up a mega. Okay. Now the reciprocal is going to be just okay. We just go the other way around and say yes, okay. Then 1 mega is going to be, no, sorry, we can say 1 kilo is going to be 1,000th of a mega. Any questions? Clear? Okay. So the same yes, okay, applies even yes, okay, if you go on the other side, on the fraction side. Clear? Okay. Just the main difference, okay, what's the difference between the reciprocals? 3 minus 2, the difference is 1. So that 3 is going to be as okay 1/10 of the one that had the minus exponent 2. But if you want to convert the other way around and say it's okay, the bigger to the smaller, then it's okay, that's going to be as okay 10 times. Is your inner mathematician still sleeping, or did he or she get a wake-up call? Or let's just go and see. We can, okay, we can put it this way. Let's say that for instance, okay, 1 deca is equal to 1/10 of a hecto. One hundredth of a kilo. 1 100,000 of a mega, and 1 over is okay 100 million of a giga. Now, on the other hand, we can say it's okay that 1 hecto is going to be equal to is okay 10 decas. This 1 hecto is going to be equal to 1/10 of a kilo. Is going to be equal to is okay 1 over 100,000. No, 1/10,000, sorry. Megas. And it's okay. Yes. We can say it's okay 1 kilo is going to be equal to 100 decas. 10 hectos. 1,000 of a mega. And 1 millionth of a giga. We can say it's okay, 1 mega is going to be equal to, yes, okay, 100,000 acres. 10,000 hectares. 1,000 kilos. And 1/1000 of a giga. Did you guys get that?
Yeah.
Okay. So where did I get all these crazy numbers from? Mainly, yes, okay. It's not that I'm okay as a stable super genius of math. But mainly, yes, okay, just looking at, okay, the difference between, yes, okay, the exponents. And as I said, okay, I'm a stable super genius of math. That's why it's okay. I created this little cheat that within seconds enables me to figure out what the answer would be. And okay, now guys, if you at any point, it's okay, get lost. Just use your currency trick. Okay, do I need to multiply or do I need to divide here? But then you have to know, okay, how many of whichever unit that you're given with compared to, okay, what your ask is, comes in what? So first is, okay, which of the two units is bigger and which is smaller? And since one is bigger and one is smaller, how many times bigger is the bigger unit than the smaller unit? Or reciprocally, or vice versa, as we may call it, or inversely, how many times smaller is the smaller unit compared to the bigger unit? That will tell you, yes, okay, which number, or yes, okay, what number you either need to multiply it with, or to, yes, okay, divide it with. If you say, okay, multiplying with a fraction is too much. Did you guys get that? Okay. And mainly, as okay, just use this line here as okay. Now I remember. I don't know, it's okay what they call it over here. It's okay when you guys do math. But this line here is okay. That was mean it's okay what they call is okay the integrals. When I learned math. Okay. But it's okay. But we may say SOK now SOK. The next thing that I may go into SOK, you may SOK use this here as a timeline. Yeah, okay. Because our next thing is going to be SOK, well, this way SOK conversion of OK as units on this side here to express, or the same could be used here, okay? Same as OK, you can convert from micros to millis, you can convert from micros to centis, you can convert from micros to decis. You can even SOK convert from micros into nanos, or vice versa. Did that make sense? Basically, yes, okay, just going to be okay. What's the difference between the exponent of this and this? That will be 6. Right?
Yeah.
So that's going to be as okay, your new exponent. Okay, maybe this way will simplify it. Now, if we, for instance, okay, we're converting something, yes, okay, expressed in millis into megas, or nano, sorry. To find, yes, okay, the worth of that millis now expressed in nanos. It would be this, which means that okay, yes, that would mean that we'd be saying yes, okay, multiplying it by a fraction, or which would mean is okay, mean that you divide it by what's the word of 10 raised to the power minus 6 is 1,000,000. Did that make sense?
Yes.
Yep.
Whereas, guys, if we went the other way around and say, well, okay, yes, we had something, yes, okay, expressed in nanos. Then you mean it's okay, just multiply by what the difference of. Yeah. But the plain difference. You can say it's okay, you want to go from here to here. Well, okay, yes, then you just multiply by the difference of the exponents. 10 raised to the power 7. Which will be, which is okay, 10 million. So how many centis do you have in a nano? The opposite, 1/10 of a million, or 1/10 of a million. How many nanos will make up a centi? 10 million. Did that make any sense?
Yeah.
Okay. But now, guys, if we go just okay, go from this side here or to this side, there's going to be okay, a little slight difference. So let's just yes, okay, and now just yes, okay, now call it yes, okay, the timeline. Where it says, okay, this is the 0 point. So year 0. So what do we have here? The first decade. First century. For 1,000 years. Million. And billion. So let's just write it as okay as exponents. That's going to be easy because we're still going to use the exponents. Yeah. Whereas on this side here, you can say it's okay, these are all going to be. Now the negative of exponents, I mean, it's okay, already that's okay, that tells us that these are all fractions. Oh, sorry. Now, guys, it is going to be the same. Let's say it's okay that we have something expressed in megas. Clear? Okay, we are given a number of a certain factor which is going to be expressed in megas. But we may be as okay, requires just okay, find the worth of that many megas using another unit. Let's say it's okay, centi. So saying that's okay, in this case, it's okay, we go from just okay, expressing I was going to find the worth of something that was expressed in megas, now being expressed in centis. We will multiply. Instead, yes, okay, multiply by the difference of the exponents. Now, guys, what's the difference between -2 and 6?
Eight.
Are you sure?
Isn't it 4?
Okay, now we have two opinions.
Yeah,
-2 and 6. One C says 8, one says 4. One is the double of the other, or one is half of the other. So which one is right now?
It's 4.
You think it's 4 too?
Yeah,
Okay,
because -2 plus like the whole number 6 would be 4.
but my idea we're talking about a difference.
Wouldn't it still be 4?
Okay, it's a democracy. You can vote whatever. So, okay, as Kathleen, you got one more vote. Anybody else?
I think it's 8.
You think it's 8? Okay.
Yeah, because the difference between getting from -2 to
No,
positive
that's
6
fine.
is 8,
Okay,
right?
no, come up with explanations. Let's just go with it.
Okay.
So now the match is even. Anybody wants to score on either team?
I think it's 8.
You think it's 8-2?
I think it's 4.
You think it's 4? Okay, you just felt okay. Okay, Angelis, you have the final vote.
I'm gonna go with 4 too.
You go in with 4-2. Okay. So, okay, guys, those of you who voted for, raise your hands. Okay. Because you are wrong. It is 6. No, it is 8, sorry. Just look at it, guys. It's okay. Okay, because, okay, what is it you doing? Just think of it this way. Okay. As you may, yes, okay, just count. 1, 2, 3, 4, 5. What the hell? Oh, okay. Sorry. 1, 2, 3, 4, 5. And then another 3, right? Okay. You can say it's okay. 6, 7, 8. Sorry. So what are you going to do now is, if that was the case, that's okay. You will multiply by 10 raised to the power -8. Clear? Whereas, guy, that's okay. Going the other way around, you have something, yes, okay, expressed in, let's say, centis. But you want to, yes, okay, express its word unit, use the unit of mega. You just be, it's okay, dividing, or it's okay, multiply by, it's okay, the difference of the exponent. Or, okay, by which here is going to be, it's okay, negative. Why? Or is it going to be a fraction? Because this is smaller, this is bigger. You says, okay, I had 10 dimes. And you go to the bank and say, well, okay, yes, I got 10 dimes. Give me, yes, okay, there are 10 dimes or worth of that 10 dimes from, yes, okay, let's say it's okay, a $10,000 bill. Just for an example. They were just, okay, well, okay, this is a $10,000 bill. Yes, okay, here. You can get this corner from it. That's how much worth just, okay, your 10 dimes or 100 dimes are. Did that make sense? Okay. So, guys, that's okay. At any point when you get lost, just think of money. I'll use that as your cheat. Okay, so you can say that's okay. But you determine that's okay, but you get how many. You can say the numerical value, yes, okay, do that multiplication and division, all dependent upon is okay if you go from a smaller unit to a bigger unit or a bigger unit to a smaller unit. Clear? Okay. Well, it's okay. On the currency side, you can say it's okay. What do you have? On the fraction part, you have quarters. Clear? Then you have dimes, right? Then you have nickels. And then you have pennies. And so and so. Well, nowadays we don't have so and so beyond that, but like, okay, just if you had something which was worth just, okay, 1,000 of a penny, you will need 100,000 of those, whatever you want to call those, to just get $1. Did that make sense? So chew along upon this fellow here, or this conversion here. I gave you the cheats. Now you may come up with, okay, a method that works for you. My method is not the ultimate. Okay. Some people say, oh, I just like to move the decimal. Okay, I don't mind. You can move the decimal in whatever way you want to. Just make sure that, okay, yes, you move the decimal in the right direction. Because if you move it in the wrong direction, then, okay, yes, your answer is going to be messed up. So no matter what, it's okay, maybe it's okay, just 2-3 things that you need to know to be able to, yes, okay, do these conversion series. First of all, know which of the two units is it that is going to be bigger or smaller. Okay. And what you do to convert from a smaller unit to express its worth in using a bigger unit, or the other way around. Clear? Okay. And you can say, okay, how many of the smallest will make up a bigger? Or how much of a fraction is it that the bigger unit is going to be as, okay, using a smaller unit? But either of those are reciprocals. Because 1 million millis make up a kilo, which means that, okay, as 1 kilo is going to be as, okay, or 1 milli is going to be as, okay, 1 millionth of a kilo. So it'll be reciprocal. So you know the conversion one way, yes, okay, the other way around is just going to be opposite or inversely to that. Okay, guys. Now that was this was probably as, okay, verbally for now, all I could give for chapter number 1. Which was, yes, okay, as the question says, okay, it's just the basics. Okay. So what was it? 2, 3, yes, okay, 3, 4 main things that we talked about. Graphs. Here, the axes, well, okay, yes. It will become relevant in a later chapter. Okay. Then we talked about the relationships. Unrelated and then related. Things that are related could be related in different ways. It could be directly related, directly proportional, which mainly mean that, okay, I said one increased, the other will increase. Yeah. It could be inversely related, which mainly mean that, okay, yes, if one increased, the other would decrease. Did that make sense? Okay. And in being, yes, okay, inversely related, it also says, okay, there was something that we called, or that we refer to as being reciprocal. That the more, yes, okay, one factor increases, there's going to be an equal but opposite or inversely decrease in the other factor because they were reciprocals. Okay. Okay. So equal and opposite, that will mainly mean that, okay, when we multiply those two, that's okay, it became one. And that's why I say it's okay, a giga is reciprocal to a nano. Because one was 1,000,000, one was 1/1,000,000. So when you multiply those, it becomes, that's okay, 1,000,000 divided by 1,000,000. Or 1,000,000 divided, or okay, multiply by 1/1,000,000. It becomes one. Clear? Okay. Just like, okay, yes, a micro is reciprocal to a mega. Because one was 1,000,000,000, one was 1/1,000,000,000. Clear? So and so and so. What I also said was that, okay, as those negative factors, or it's okay, decimal factors or fractions could be expressed as fraction, one over this, one over that, one or so, one or so. But please keep in mind that, okay, yes, those fractions could also be expressed as, sorry guys, decimal numbers. Those would be as, okay, 0 point, tick, 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 so and so. Okay, XY number of zeros, and then, okay, yes, a number. And both of them, yes, okay, whether they were multiples or fractions, could be expressed with the exponents. Clear? Okay. 10 raised to the power 3, 6, 8, 9, 2 or so, or minus. Now, whenever you have, it's okay, a negative exponent, 10 raised to the power -2, -3, -4, -5, so on and so on. That negative sign with the exponent automatically will tell you that this is a fraction of the whole number, of the basic unit. Did that make sense? Okay. So you may say, it's okay, 1 millisecond. What will 1 millisecond mean? That if you took a second and divided it into 1,000 equal parts, each of that part of a second will be, as okay, 1 millisecond. Clear? Okay. So 1 millisecond was going to be, as okay, 1,000 of a second. But you mainly will say, it's okay, 1,000 milliseconds will make up 1 second. You can go on, yes, okay, you can take, yes, okay, your measuring tape or ruler or so and so. and say, well, okay, yes, there's a distance which is 100 centimeters. That 100 centimeters is 1 meter. So those 100 centimeters makes up a meter, mainly because that centimeter meant 1/100th of a meter. Okay. Here you guys may call it a penny. In some setups, yes, okay, the 100th of, okay, yes, the basic currency is going to be as, okay, a cent. Have any of you ever received a Canadian penny?
Received a what?
A Canadian penny?
Yes.
They look like American pennies, right? The only thing that's difference is, what's the
What's
difference?
on them?
Huh?
The pictures that are on them?
Okay, so what do you have on an American penny?
A president, and then
Okay, which president? I'm kind of difficult.
is Abraham Lincoln?
Abraham Lincoln. Okay, and what's on the other side then?
I forget what's on the other side.
Uh, okay, Teresa, that's going to be your homework to find what's on the other side of a penny. If I think it very well could be as okay the Lincoln Memorial, right? It depends because it's okay. Some newer pennies that's okay have something different on them. So anyways, please do that. But what's on a Canadian penny then? Or cent?
I know that like the giant, like there's a giant one and a cent sign on one side. I don't remember what's on the other side, but it could be different because there's different.
Okay, the
things.
one penny I received had okay as a big maple leaf, like they have on the flag.
Oh, I don't have any maple
Okay,
leaves.
okay. Maybe you use them to buy as okay thing from a vending machine now. Okay, well there's okay a picture of the Queen. Okay, peace be with that. Okay, guys. So you guys want to do it this way? You got some good 19 nice questions at the end of the chapter. And I think there's some yes, okay, 20 or 21 or 22 questions at the end of the book. That exam review. Let me guys give you guys the page numbers so you have that as well. Oh my God, where are we? Scooby-Doo. Yes, okay. Page 423. Clear? Okay, so from question number 1 to question number, yes, okay, 22. Those are questions from, are related to chapter 1, right? Is that fair?
What pages did you say?
At the end of your chapter, right? The
Yeah.
chapter we just finished.
Chapter 1.
Chapter 1. Okay, what do you have? You have a total of some nice 19 questions. Good. Then just go to yes, okay, your exam review at the end of the book. Where chapter number 24 finishes. Well, okay, there's no question for chapter number 24. But after that, yes, okay, you have what says exam review, right? And the first one should say, yes, okay, the basics. Or the glare of the page, yes, okay, the basics. And I think it's the first 22 questions.
Yeah, it's on page 423.
423 to 427. So the first 22 questions is about the basics, what we have been talking about. Did you guys get that?
Yep.
Okay. So in between each bite, eat your lunch. Try to just, go over these questions here and see if you can answer them by covering the answers. Okay. And when we come back, we will look at these together and see if you can reach to an agreement. Okay. Does that sound fair? So would it be fair enough that I say I see you guys back at 12? Oh, not 12, sorry. Let's say it's 110. Good. Have fun tonight, guys. Okay, guys. Welcome back. And you guys try to look at the questions. Okay. Now, pretty much okay, guys. This is how I do it. Now, for some of the questions, that's okay. You can try to rephrase it as, okay, well, how is it that, okay, other options which may not be right for the question given in the book, or how could the question have been worded, phrased, or written or given, which were made as, okay, some of the other options, the right answer. Okay, so we're going to talk a bit about that as well. I'll try to, yes, okay, do that as well. Okay, guys, so what do we have? I mean, it's okay. Maybe it's okay. Just we'll start with, okay, yes, the questions. Well, question 1 on page 1. Or page, no, not page 1, sorry. Page 7. Okay, so the questions after the chapter. So how are the size of a tree really and its age related? And you can mean this as, okay, as the older that tree gets, its size increases. So you can say, okay, now you can say increase in age. Guys, when it's okay, when the arrows go like this, you want that way. This increase and this increase. That mean that they are directly proportional, or you can call it, okay, directly related. Okay. Now, how are the height of a person and the color of his automobile related? Well, okay. They are unrelated. Okay. How is the age of a loaf of bread related to its freshness? Like Hermione says, okay, again, it's okay. For greater number of days, yes, okay, loaf of bread has been there. Well, okay, that's going to cause it to be, yes, okay, less fresh. And this relationship here is okay. When one increases, another decreases, that's going to be, yes, okay, inversely related. Yeah, okay. Now, which of the following are an appropriate unit for area? Now, you guys remember that I said it's okay, area, that was going to be, it's okay, any unit of distance, or for instance, length, which are going to be squared. Okay. So seconds, guys, that is not a unit of area. That's a unit of time. Now yards, well, okay, yes, it is a unit of distance or length, but it is not squared here, so it's okay. That's not going to be the answer. Right, okay. Inches. Again, yes, okay, inches a unit of distance or length. But again, yes, okay, here they are not talking of square inches, but just plain inches. So that's not the unit of area either. Centimeter cube. Now, guys, this centimeter cube here is okay. That would have been the unit of volume. Okay, because what we said was any unit of distance or length cubed would be volume. So the only one that we have, which is a unit of area, is square inch. Now, please keep in mind, guys, this square inch can also be written as, okay, as inches square. Clear? Okay. Had it said inches cube, that would have been a unit of volume and not area. Did you guys get that?
Yep.
Good. Question number 5. So which of the following is not, please, not an appropriate unit for volume? Okay. Now this question could also be a label as, okay, name like, okay, the word is. All of the following will be as, okay, appropriate unit of volume except from. Okay, so the only thing is, okay, we need to find out is, okay, which is not a volume. Now, cubic mile. All this, okay, they wrote it out as, okay, as cubic mile. But that means they're going to be saying the same as, okay, as miles cube. But we know that, okay, this here is a unit of distance. And when that unit of distance is cubed, that becomes a volume. It's going to be a big volume, but it's still a volume. Okay. Now, yes, okay, from the gas station, yes, okay, from the grocery store, gallon is a unit of volume. That gallon of milk, that's going to be a volume. Now, the next thing is they go and say, yes, okay, centimeter. No squares, no cubes, nothing. So here is, okay, that is just a plain unit of distance. Clear? Had it been squared, it would have been area. Had it been cubed, it would have been a volume. But yes, okay, here it is neither squared nor cubed. So this is not a unit of volume. Okay, we already found the answer, but we can still go on to the next one. It says, okay, we just did it. Okay, centimeters cube. There was a unit of volume. And again, it's okay, your pint. Okay, again, it's okay, it was a unit of volume. That's, as I said, at an earlier time in a different course, the amount of blood that you donate if you go for a blood donation is 1 pint. Okay. Blood banks, blood drives, and things like that. It's okay. If somebody is in for, it's okay, donating blood, that's going to be, it's okay, the standard volume of blood that they may take from you. And then you get a drink. Okay, usually they will give you, it's okay, a little carton of juice or something. Okay, guys. Question number 6. And again, yes, okay, just as I said earlier, yes, okay, another way of asking, yes, okay, which of the following is not. So yes, okay, they come up with that wording. Okay, but what they're asking about here is, okay, all of the following are measures of length except. So yes, okay, we are looking for length, or we can say, okay, any unit of distance. Okay. Well, okay, as we have a mile, okay, that's a unit of length or distance. So that's not the answer that we are looking for, because we are looking for not a length or distance. We say it's okay, an inch. Okay, yes, that's a unit of length and distance as well. We said millimeter. Clear. Now that's going to be as okay, a unit of length or distance as well. We said second. That is not a unit of distance. Right? Rather, as a matter of fact, this is a unit of time. And the last one is km, which is going to be, it's okay, a kilometer. Now, guys, how many decameters do we have in a kilometer? Jesus. How many decameters do we have in a kilometer?
100.
We got 100. Now, how many centimeters do we have in a kilometer? How many centimeters do we have in a kilometer?
$100,000.
100,000. The cheat here, it says, okay, 1,000 is a kilo, centi is 100. Okay. Yes, if I go the other way around and say it's okay, then how many centimeters did you have? Or how many kilometers did you have in a centimeter? How many kilometers do you have in a centimeter? Just the opposite of what Jennifer just said. Or inversely to what Jennifer said. Because that was the number of centimeters in a kilometer. But if I go the other way around and say, how many kilometers do you have in a centimeter? That's going to be as okay, 100,000 of a kilometer is going to be a centimeter. Did that make any sense?
So there's 100,000 centimeters in a kilometer?
Yes.
Okay.
What's going to be the exponent for 100,000? 10 raised to the power 5. What does 10 raised to the power 5 means? 10 multiplied by 10 multiplied by 10 multiplied by 10 multiplied by 10. So 10 multiplied by 10 is 100, multiplied by 10 is 1,000, multiplied by 10 is 10,000, multiplied by 10 is 100,000. That's fine. Let's see. Now list these metric terms in an increasing order. Now, guys, two things are yes, okay. We can say okay, two words that you may come across. Yes, okay. In different chapters, in different things, that's okay. One is going to be as okay when we say it's okay, an increasing order. Okay, so what will mean to yes, okay, arrange things in an increasing order. That you may yes, okay, start from small or less to big or more. Is that clear?
Yep.
Right, okay. Now, the opposite of increasing order is just going to be as okay, where we can call it decreasing order. So that's just going to be the opposite, where you actually just okay go from big to small, right? Okay, or you can say it's okay from less to no, it's okay from more to less. Or we can actually say it's okay, yes, okay, a countdown. Right, okay. When you go with a countdown, you start from a bigger number. Okay, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Damn. Right, okay. Did that make sense? Okay. So yes, okay, this kind of yes, okay, wordings yes, okay, is going to yes, okay, come again and again and again and again. So an increasing order means yes, okay, just start as okay, you start from a smaller or is less and go to the bigger. Where decreasing is just going to be the opposite. That you start big, but okay, as you go small. Yeah, okay. So what I actually have given us here is okay, is a list of different you can say it's okay, metric units or metric terms. Now, when they say it's okay, arrange them in the increasing order, that mainly means it's okay that now the cheat is, well, okay, not cheat. You start with the smallest one. Okay, so the one that is going to be the smallest one here is micro. Clear, okay. Then you go to milli. Milli is bigger than micro. Okay. Then you go to deci. Then you go to deca. Then you go to hecto. Then you go to mega. So that mainly is okay in your increasing order. Whereas okay, it giving you is okay the same units, but it's saying it's okay in a decreasing order. Then you go with first you go mega, okay. Then you go deca. Then you okay. It's like then you go hecto. Sorry. Then you go deca. Then you go deci. Then you go milli. Then you go micro. So that was in a decreasing order. Clear? Okay. Now, question number 8 is mainly as okay, similar, okay, but what they're asking about is in a decreasing order. So as okay, when you go in decreasing order, it's okay, you start big and just go down to the smaller units. And of course, yes, okay, we have different units. Okay. Okay. So the units that we have are okay, nano, centi, giga, kilo, hecto, and micro. Okay. So, but since they ask us to just okay, going decreasing order, well, okay, what do we do? We will start with the biggest one. Which is the biggest one of all these? Giga. Clear? Okay. Next smaller is kilo. Then we have hecto. Okay. Then we have centi. Then we have micro. Then we have nano. So that was in a decreasing order. Oppositely speaking, guys, that's okay. If you go in an increasing order, you start from the smallest and just go bigger and bigger. So that's okay. In that case, if you start with nano, then you go center, then you go hecto, then you go kilo, then you go, sorry, nano, micro, then you go centi, sorry. Then you go hectare, then you go kilo, then you go giga. Did you guys get that?
Yeah.
Okay, guys, now question number 9. Now, how many milliliters are there in 8 liters of milk? Oh, sorry. Okay, I just went to grocery store. Anyways, so the may as okay say that 8 liters is equal to how many milliliters? Okay, now we can mainly says, okay, here, guys, okay. 8, we just go 8. So the main thing is, okay, just going to just, okay, and if you know that, okay, yes, 1 liter is equal to how many milliliters? Now, a liter was a bigger unit, milliliter was a smaller unit. So what I said was, okay, is when you want to, is okay, where is okay. Express or determine the worth of a bigger unit using a smaller unit. You will multiply by as okay, how many of these smaller units here you had in a bigger unit, which is 1,000. So that mainly means that okay, yes, 8 liters is going to be equal to 8,000 milliliters. Is that clear?
Yeah.
Okay. Where I had asked the opposite way and say, yes, okay, let's just put it this way. That they ask, yes, okay, 8 milliliters is equal to, yes, okay, how many liters? Then you say, yes, okay, well, okay, good. 8 is 8. Well, it's okay, okay. And you can say, okay, liter is liter. But okay, yes. What's the worth of milli? That's okay. 1/1000. So 8 milliliters is going to be equal to 8/1000 of a liter. Did that make sense?
Yep.
Or you can even say, it's okay, how can this 8/1000 of a liter also be written? Eight is 8. It is 10 raised to the power minus 3 here is, okay, yes, that. 1 over 1,000, and okay, yes, your liter is the liter. So 8,000 liters is 8,000 milliliters, sorry, is what you have in 8 liters. 800 would have been the same, or would have been the correct answer had they asked you as, okay, how many what you want to call centiliters do you have in 8 liters? Clear, okay. 80 would have been, yes, okay, how many deciliters do you have in 8 liters? It can't be 8. Had the answer been 8, then okay, that would mainly been saying, yes, okay, that milliliters and liters are the same thing. They are not. They are both units of volume, but size-wise or value-wise, they are not the same. Clear, okay. And 8 over, yes, okay, 1 over 8 would have been asked had that says, okay, 8 liters is equal to how many decaliters? Yes. Question number 10. Now, that's okay. A pretty similar question, but that's okay. Okay. Where it says, okay, now how many centimeters are there in 3 meters? So again, 3 meters, and then mainly it's okay, asking us, okay, how many? Yes, okay, centimeters. Now, just so you guys remember, okay, that this centimeter here, that's actually going to be, it's okay, 1/100 of a meter. So we can again go and say, that's okay. Now, where we go is, okay, we convert from a bigger unit to a smaller unit. Clear? Okay, where we can again say, it's okay, 3 would be 3. But we're expressing is okay the worth of a bigger unit, now using a smaller unit. So we mean is okay, multiply. Multiply by what? This. So we have 300 centimeters is the same as 3 meters. But had they asked us the other way, that says, okay, 300 centimeters is equal to how many meters? Again, that's okay. We can still say that, okay, as 3 is 3. But since we now, yes, okay, are going from a smaller unit to determine, yes, okay, it's worth in a bigger unit. Well, okay, yes, we can say it's okay. It may be as okay is of a meter, because this means yes, okay, is worth of a centime. Or since it is negative, we can say it's okay, it can be given as a fraction. E over 100 of a meter. Or we can give it as a fraction. It can also be expressed as a decimal. Okay. So 3 centimeters, sorry, not 3 centimeters would have been 3/100ths of a meter, or 0.03 of a meter. Or it could be written as 3 multiplied by 10 raised to the power 2 of a meter. Any questions, guys?
No.
So how many of you are already thrown off? Or is this too much math that you signed up for? It's okay. It will come with a little practice. Okay. Okay. So, but the way to get the practice is okay, is doing it this way here. Or you is okay, flipping a little around with the numbers. And I say, okay. Otherwise, it could be as okay, endless numbers of questions in the book. Okay. Good. Okay. So we are at okay, yes, question. Oops, shit, what the fuck? Doing this again with me. Okay. Okay, that's better. So we can say it's okay, question 11. So again, yes, okay, what they're asking us here is, well, okay, yes, we have 3,000 meters. But they're asking us, is okay, how many kilometers is that going to be? Now, guys, if you just look here, that's okay. Maybe not the traditional way of doing it, but that's always a cheat. We can say, okay, 3 would be the 3. Meter is what we have here. Is okay, is meter. And what this 1,000 here actually is equal to is your 1,000. So your 3,000 meters would actually is okay be 3 meters or 3 kilometers. Is that clear? You can even look at it this way and say, okay, well, 3 is 3. Also is 3 is 3. You can say, it's okay, meter is meter, meter is meter. And okay, this 1,000 here will be as okay, 3 raised to the power 3. The value of K is, which is kilo, is 1,000, which also can be written as 3 raised to the power 3. So this is going to be as okay, the numerical number of kilometers that you have from 3,000 meters. Did you guys get that?
Yeah.
Good. Now, if I just flip it around and say it's okay, 3,000 kilometers is equal to how many meters? Or we can do this way. Say it's okay, 3,000 kilometers equals to how many meters?
It's 3 million, right?
What did you say, Christian?
Is that 3 million meters?
3 million,
3,000.
3,000. Okay. Anybody else with a different number? We have 3 million and 3,000.
No, it is 3 million. I was wrong. It's 3 million.
You're wrong. Yes, of course. Because if you go by okay, at least okay, you see where your mistake was? Okay. Okay. You can either say it's okay, I mean 3,000 if meter and then a kilometer was the same. Clear? Okay. That would be the same as saying it's okay. An inch and a mile is the same as well. Okay. An inch and a mile, there's a hell of a difference between those two. Okay. If that's the case, that's okay. You may be able to jump, yes, okay. 700 miles. So it is 3 million. 1,000 from the 3,000, and then another 1,000 from the kilo. Clear? Okay, so 1,000 thousands makes a million. Or 1 was 10 raised to the power 3. The kilo was a 10 raised to the power 3. So that becomes 10 raised to the power 6, which is a million. Okay, so you have 300 or 3 million, sorry, meters in 3,000 kilometers. Happy journey. Hey guys. Now, what is the reciprocal of 100?
0.01.
It can be 1 over 100, right? Yeah. This 1 over 100, my dear, can also be 0.01. Clear? Which also can be this. Did you guys get that?
Yep.
So we can, the other way around, also say it's okay that the reciprocal of any of these would be 100. So you may be given a question where it says, okay, what is the reciprocal of 0.01? It's going to be 100. Okay. What's the reciprocal of 1 over 100? It's going to be 100. Did you guys get that?
Yep.
Yes.
Now, what is the reciprocal of, what the hell? 1 over 8. Now, reciprocal of 1 over 8 is 8. Yeah. What could be another way of saying it's okay, 1 over 8 in a decimal form? Does anybody know what the reciprocal of 1 over 8 would be?
Isn't it just
0.8?
0.8?
Huh?
Just 0.8.
0.125.
It's not 0.8, my dear.
0.125.
Huh?
0.125.
Exactly. My dear, what 0.8 would mean? Or 0.8? Or had been 8 over 10.
Yeah, that's my bad.
Clear? Okay. And we can again, it's okay, go on and say it's okay. The 10th of a dollar is a dime. So if you have 8 dimes, how many cents do you have? 80 cents. But those 80 cents is going to be as okay 0.8, or it's going to be as okay 8 cents of a dollar. So just put it this way, and that's okay. It's 1/4, for instance, okay, that's going to be as okay 0.25. And you just half that. And that's where you get 0.125. Okay, and some of you may say, well, okay, this writes, yes, okay, this reads or 0.25. You'll say, but that's only 25. And 0.125 reads 125. Well, that's because, okay, it's a decimal number. Okay, so this is actually, that's okay, a smaller number than this one. Okay, guys, let's look at a question that looks like, okay, it's a little bit like ultrasounds. Because, okay, it means it's okay, how many hertz are there in 3 megahertz? So again, guys, again, we can say it's okay, 3 is 3. It's okay, the hertz are hertz. And what's the worth of a mega? Million. Now this million can be as okay 6 zeros, or it can be it's Oh, sorry, 6. Damn it. Like that. Okay. Where 3 is still 3. This or these 6 zeros here is your mega, and okay, yes, the hertz is still the hertz. Is that clear?
Yeah.
Okay. So 3,000 would have been the answer that they said are there in 3 kilohertz. Because okay, your 3 is 3. Well, okay, yes, the hertz is hertz. Right, okay. Where you can say is okay, 1,000 would have been your kilo. Okay. Now, guys, frequency is probably not going to be a unit that you will see in fractions. You will not see as okay, millihertz or something like that. If that's the case, that our main meter of phase is going to take a long time for a cycle of a sound wave to be completed. Okay, guys. Now, how many millimeters are contained in a jar of, or milliliters, sorry, are contained in a jar of 5 liters? So it's only a matter of, okay, let's determine how many millis or milliliters do you have in a jar of 5 liters? So you can say how many milliliters makes up a liter. How many milliliters makes up a liter?
1,000.
1,000. So 1,000 will be 1,000 multiplied by 5 becomes 5,000. Okay. Okay, how many liters are contained in 80 milliliters of fluid? Whoopsie, what the? Why are you starting doing this for me? Eighty milliliters of fluid is equal to how many liters? Now to begin with, we can say it's okay that 80 is 80. Now mainly that's okay because it's okay, milliliter is a smaller liter or smaller unit. This is a bigger unit. Okay, how smaller is this going to be? Is the milliliter? Is 1,000 of a liter. Right? That's your solution right there. So it maybe becomes 80. Then you can say it's okay, it's divided by 1,000. Now, if you want to, you can go bump, bump. What do you have? 80 or 8 divided by 100. This becomes 0.08 liters. Now, some of you will say, Mike, there's a 0 here. Well, okay, you can put as many zeros here. It's not really going to just make any difference. Here, I can write 0.008 and just put unlimited zeros afterward. This is the value. The value of these zeros only apply if there comes a number after, let's say all those, we can say any number, 2, it could be 3 or 7. Then these zeros ever have a value. Did that make sense? So 0.08 or 0.080 0 is the same. Okay. Okay, guys. Now, if you answer the question in the review as well regularly, well and good. If not, you still have time to do them. Okay. But also it's try to flip things around like this, just to give yourself a little bit practice. Clear? Okay. And practice the old way, no calculators. Okay. Lillian, you are not aware that on your test you are not allowed to use calculators. Okay, dear? Okay. Why would I be so mean and not allow you to have a calculator? Because when you go for your board, there is no calculator allowed either. Then you're going to have a problem over there. And you pay a lot of money for that test. Okay. So, okay, guys. I guess I will see you guys tomorrow unless somebody have a last word of wisdom. No word of wisdom? Okay, then let me say the word of wisdom. Goodbye.
Bye.
Okay.
See you tomorrow.
Bye-bye. Okay.
We'll
have
see you
fun.
tomorrow.
Okay. Take care, guys.